are you, everybody who is watching this video? My name is Olenjolain Singo from United Republic of Tanzania. This is our national flag. I would like to welcome you into our online program that's called the Tanzania. It's called the Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. Once again, I would like to welcome you into our YouTube channel that's called Tanzania Online A-Level Safety School in square bracket M. Well, so in simple, just in brief, we in this online program, we have online school. We have a vision, and this is the vision that we have. We like to be a part of people who used to prepare a certain community of youth, or it means that students who are ready to take the classroom instructions in science and mathematics, and then combine it with the spiritual knowledge of the Word of God, right? And in order to solve real life problems in our communities. It sounds like something impossible in our mind, but I believe that is possible. However, that it won't be a business of a single day or a business of in one lecture, in one session, but I know it's a process, but I'm ready to play my part in order to achieve that process. So if you're watching this video right now, you're a student or you're parents or you're guardians, always in all our sessions you have to expect something new that we are going to do, and even we are going to challenge you to think differently. But one of your responsibility is not just to take the informations and use them for the exam, but also you have to make sure that you take these informations and you think to yourself, where can I apply in order to solve a real life problem? That's the challenge that will be always challenging you, because our main objective is to see our students, whether during the time when they are studying advanced education, so after they graduate, they are solving real life problems, because we are born to solve problems. Either a single problem, it's a real life problem, or more than one problem. So that's what we're expecting. Passing for exam is one of our specific objective, but it's not our main objective. So you have to understand about that. However, that our educational system means that in Tanzania focusing more on preparing students to pass exams. But that is one side. So for myself, I will include it because it's a subset of my project. So in my project, what the students used to seek in schools to pass for exams is just a subset of what I want to contribute for the nation. Okay, so again, in our YouTube channels, we'll upload more than 400 videos. So we insist every student to register himself or herself by having an email, and then by using that official email, you can sign in YouTube, and you have to make sure that you subscribe. You click the buttons of subscribe, then against an icons of the bell appear. Then you have to choose, and you choose the options of all. Why should you subscribe? That's a very important question. The main objective or the main advantage that you'll get after you subscribe means that once we add a new video, the YouTube community will be responsible to give you notification that OLENJOLAI has added a new video in his channel, right? So you'll be notified once you are online. Okay? Again, in case that you feel from your heart that you want to offer Thanksgiving, because the session number. This is session, so we had 060, we had session 60, then this is session 7. This is session 7. Okay, so this is session 7. So, once, in case that you feel from your heart that you want to offer your Thanksgivings in order to be a part of running costly for this program, don't hesitate yourself to send your Thanksgivings to this phone number, 0759745331. So now let us go to the business that we have. Okay? So let us go to the business that we have. And this is the moment that now I want to take you into the lecture. Well, so let us begin this material. So we are in departments of advanced chemistry. The subject of the day is advanced chemistry. And we have the main topic, or the main topic is called the advanced organic chemistry. And the topic or the chapter is called advanced general introductions of advanced organic chemistry. and this is session 7. So 6 sessions have already been taught. Make sure that you go through them before you come to this session. Okay. So let us do a quick review. Let us do a quick review. Quick review of what? Of session 06. You have session 06A, 06B. Possibly you can find even 06C. So that's the way that we break our videos into smaller pieces. First of all, we taught you about the rules, or we taught something about, we introduced you for the first time something called in advanced organic chemistry as mechanism, right? So in this mechanism, we talked about rules. How many rules did we teach you? So we had 3 rules. Rule number 1, rule number 2, rule number 3, rule number 4. Okay? So it depends. So he said that we can use this symbol or this symbol just to show that this is 1 electron will be transferred, has been transferred. And also you can use the full arrow, such as this one or this one. This will say that 2 electrons have been transferred. But again, there are the rules that dealing with what the pi bond between identical atoms, such as this one. Then we say that the arrows should start from the center and pass through the carbons, which will become a nucleophile. It means that we receive, accommodate the incoming electrophile, right? So we say that this is the way that the reaction is used to happen, and finally we find this one become partially negative, this one partially positive. So it means electrophile will come and attach here, and nucleophile will be attached here. Against that, I talked about the bonds, okay, bonds that we form between the non-identical atoms, and this is in case that we find we have double bond like between carbons and oxygen. So one is pi bond, the other one is sigma bond, right? So if that's the case, it means that these bonds will break like this one, and this one will become partially negative, and these carbons will become partially positive, right? So that is, and then let's even discuss something about ammonia. Okay, ammonia which has lone pair, we discussed about that, 1 lone pair. And then, yes, so we had another rules dealing with what? With lone pair. So we have almost, I taught you 4 rules, and those rules are very important because, for example, this is the one of reactions or preparations of alkane, right? So if you want to prepare alkane, for example, sane, you can prepare by using what? By hydrolysis. It's called hydrolysis of Grignard reagent. This is Grignard reagent. Okay? So this is the way that the reactions take place, and the final product, the end product is, if you add these hydrogens here, then we have what? So the end product, for example, is CH3, CH3, and then plus what? Plus magnesium hydroxide chlorine. We are very interested in the organic part. So you see how the reactions is simple, and then it's very interesting compared to if you claim what will be the end product, right? So this was one of the homework that I gave, but private homework for my physical students. So in case that you're not familiar with that, don't get shocked. Don't worry, I will teach you. We have a complete 1 session of preparations of 40 of alkane, right? So today I want to teach you this new part or new subtopic. Okay, that's called types of organic reactions. Types of organic reactions. Say types of organic reactions. Well, in chemistry, during our form 2 education, or for other, because this is class 13, maybe during the class 10, we have been taught about types of chemical reactions in what? In chemistry. Okay? In chemistry. So just see the overview. Let me give you the overview, okay? So that I can take you to what we have to do. The overview. The overview is this one. We said that during the form 2 we learned about types of reactions, okay, in chemistry. We learned about what? Combination reaction. Combination what? Reaction. For example, combination of reactions, if you have hydrogen combines with chlorine, then you form what? 2 molecules of hydrogen chloride. So this is gaseous and this is gaseous. Then we learn about what? Decomposition reaction. Decomposition reaction. So decomposition reactions, you find that maybe a certain compounds decompose to form something else, right? So for example, one of the examples of decomposition reactions, sodium, calcium, calcium carbonate, if I'm not mistaken. So if it undergo decomposition, if I'm not mistaken, you get calcium oxide, or calcium oxide plus carbon dioxide, right? That's one of the examples. The third example, the types of reactions, say neutralization reaction. You know about this one, because when you hear about the types of chemical reaction, in your mind, what's coming in your mind is types of those organic chemical reactions that you know. And it is good. So then, neutralization reaction. So neutralization reaction is when we have sodium hydroxide, when acid reacts with base. Plus what? Let's say plus hydrochloric acid. So the end products will be salt, sodium chloride, plus what? Water. But again, you have another reaction which we call double decomposition. Double decomposition. This double decomposition reactions is in case that you have two salt molecules. Salt, for example, that is sodium chloride react with calcium sulfate. So this is double decomposition. This decompose and this decompose. Then product, you might find that is sodium sulfate plus what? Plus calcium chloride. Then the last reaction that we learned in O level is called what? Pardon? Redox that we used to find in A level, if I'm not mistaken. There's another type of reactions. How do they call it?
Precipitation.
No. Another one. Combination, decomposition, neutralization, double decomposition. Another one?
Displacement.
Displacement reaction. Yeah. So displacement what? Reaction. So displacement reaction is in case that, for instance, we have hydrochloric acid, and then, for example, we have sodium chloride. Sodium chloride. Then we have reactions with what? Sodium chloride, because we want a metal to come and displace it. For example, if we react with what? Magnesium. So the end products will be magnesium chloride plus chlorinic acid. So it's a magnesium will displace what? Sodium. So these are the common 5 types of what? Of chemical reactions or reactions in chemistry. Redox we used to find in the A level, especially for electrochemistry. However, that during the O level, some teachers they can introduce to it. There's a redox reaction, which is a reaction which involves what? Oxidation and reduction. But if you ask it further what the means of oxidation and reduction, it's another story. Okay, so when you say about types of organic reactions, we are introducing some other types of reactions, and this specifically we find them in organic chemistry, right? So these are the other types of reactions. So we say that organic compounds undergo some types of reaction. Reactions. Some types of reactions depending on the reactants or reagents, depending on the reagents or reactants. But reactants in the particular reaction. So we say that organic compounds undergo some types of reactions, okay, depending on the reagents or reactants. When you say the reagents or reactants, we mean that depending on whether nucleophile and electrophile are reacting, or free radical and free radical reacting. So we say that when we say about organic reagents, mainly we classify them into three types: nucleophile, electrophile, and the free radical. So we say that there are three types. There are three types of what? There are three types of organic reactions. There are three types of organic reactions that are: one, we have a reaction that we call addition reaction. Say addition reaction. So say that addition reaction. Addition reaction. Secondly, we have substitution reaction. Thirdly, we have elimination reaction. So you see that in all the three types of reactions, of organic reactions, we didn't mention what? We didn't mention neutralizations or combination decompositions or double decompositions or displacement. So that's why that I give you the overview of what you know, so that I can build these concepts of types of organic reactions on the foundations that you had during your O-level education. So let us take a study of each of the reactions. I would like to teach you in advance the first type of reaction, which we call the addition reaction. Say with me, addition reaction. Very interesting reaction. And you know always, this is common for me. What is addition reaction? That is my starting point. What is addition reaction? So reaction, sometimes I can write in short like this one. What is additional reaction? Reaction. Okay, reaction. So, but anyway, maybe to avoid confusion for you, I can write just the word entire. So this will be the first question for me, and the first question for you also. For today, what is addition reaction? Okay, so it's an addition reaction. Addition reaction is the type of organic reaction is a type of organic reaction. This is the one type of organic reaction in which the group of atoms are added. Added to the organic compounds. Added to the organic compound without removing any atom, without removing an atom from that that atom. That is the definition of what addition reaction. What's addition reaction? It's the type of organic reaction in which group of atom, either one atom or group of atoms, in which a group of atoms, so in which the atom or group of atoms are added, right? Or is added to the organic compounds without removing what? Without removing any atom from that atom. So we just add, but we don't remove. We just add, but we don't remove. So we say that is a type of organic reactions in which that a group of atoms or atom are added to the organic compounds without any removing of atom, without removing any atom from that atom, from that compound. Excuse me, from that compound. So let me explain this definition. We say that addition reaction, we have, suppose that here we have a certain organic compound. Listen carefully. Organic compound. So this organic compound will undergo addition reaction if we add a certain atom, let's say X, right? We just take an atom X or a group of compounds called the X, and we add it to organic compound without removing any atoms from organic compound. When you say without removing, for example, for instance, okay, I will give you an example. Okay, I will give you an example later on. So for instance, that we have, let's say, we have this CH3, then CH2, or CH, then CH2. This is what propene. Then they can undergo hydrolysis. So hydrolysis of what? Of unsaturated hydrocarbons. So here you have that bond. So what happens if these reactions will undergo, if propene will undergo additional reactions, we are adding either hydrogens or hydroxide. We are adding, for instance, for these reactions, means that the bond between hydrogen and oxygen break. So we have what? We are going to have hydrogen, which is partially positive, and hydroxide, which is partially negative. So this is that bond. So this is the double bonds, pi bonds will break down, right? And that's, we are going to have electrophilic carbons and electrophilic carbon. So we'll be adding this electrophile to the nucleophilic carbon, and we add this nucleophile into electrophilic carbon. So we are only adding molecules onto the propene, but we don't remove any atom from propene. Right? That's the meaning of additional reaction. So you can take even the keywords that addition reactions, simply in organic, we are adding atoms into organic compounds, but we don't, without removing any atom from it. Right? Addition reaction is common in unsaturated compounds which have localized the pi bonds electrons pair. So again, this is another point to note. Addition reaction is common. Addition reaction is common for what? For unsaturated what? For unsaturated hydrocarbons. Hydrocarbons, unsaturated hydrocarbons, which contain localized pi bond. Localized pi bond electron pair. Electrons pair. Okay? Example of these unsaturated hydrocarbons that undergo these additional reactions. Example we have alkane, all alkanes, and all the alkenes. right? Excuse me. So alkynes, and the alkenes. So alkynes, they contain triple bond, and alkenes, they contain double bond. So when you say unsaturated hydrocarbons, it means that these are hydrocarbons which contains pi bond. That's a simple meaning. Which contain at least one pi bond. So if that's the case now, we say that there are two types. There are two types of 40 of addition reaction. Two types of addition reaction. Two types of addition reaction, which are the first one is called what? So the first one is called nucleophilic addition reaction. Nucleophilic addition reaction. The second one is called the electrophilic addition reaction. Electrophilic addition reaction. So you have those two types of what additional reaction. Electrophilic addition reaction and nucleophilic addition reaction. So let us discuss each type of that organic reaction. Let us begin with what? So 121. So let us begin with electrophilic addition reaction. Electrophilic addition reaction. Say electrophilic addition reaction. This is the fundamental equation. What is electrophilic? So what is electrophilic addition reaction? What is electrophilic addition reaction? That's the question. Okay? So simply say that electrophilic addition reaction, say that is the type of addition reaction. It's a type of addition reaction. So it's a type of addition reaction. Type of addition reaction in which the electrophile is added. Electrophile is added first. Okay, before additions of 40 of nucleophile. Added first, followed by addition of the nucleophile. The electrophile is added first to the organic compound. The organic compound, right? And they follow by addition of 40 of nucleophile to that organic compound. So we say that this is the type of organic reaction, so it's the types of addition reaction in which, right, the types of addition reaction in which, the type of addition reaction in which the electrophile is added first to the organic compounds and followed by addition of 40 of additions of nucleophile. So you add the electrophile first and then you count 40. So the overall reaction, for example, general reaction. simply say that we have, let's say, organic compound. We have a certain organic compound which is should be unsaturated, and then we add what first? We add the electrophile first, then afterwards we add what? Nucleophile. So this electrophile will be added here first, and then so this is first, and then nucleophile will be added second. So example, okay, don't remember if this, I think, I don't know whether, you can write, I don't remember your numbering, but for me it's example 17. Complete, okay, complete the following reactions. Complete the following reactions. Yo guys, that example. Huh? Complete the following reaction.
Example 9.
Huh?
Example 9.
Example 9. So according to your notes, it means this is example 9, okay? Tertiary hydrolysis of unsaturated hydrocarbons under the presence of 40 sulfuric acid. Presence of sulfuric acid. For me, I'll do this. CH2 hydrogen. This is sulfuric acid. So this is the hydrolysis of unsaturated hydrocarbons. It means hydrolysis of what? Hydrolysis of alkene. Hydrolysis of alkene. This is session 7, types of organic reaction. So here it is. So the first one will be your homework. This will be homework 7, and I will do for Roman 2 solution. So the question asks you to complete the following reactions, but I will do the mechanism. Okay, so let me write everything here. Here you have CH2, C3, and CH2, with carbon, double bond carbon. You have hydrogen here, and then here we have 2 hydrogens. So remember that this is an example of what? Electrophilic addition reaction. So electrophilic addition reaction. Listen careful, stop writing. Okay. So water contains nucleophile, contains lone pair, right? And then remember that in some of organic reactions, these are the conditions under the presence of what sulfuric acid is a condition. In some of organic reaction, what I want to tell you that even these reactions, even these conditions might be involved in as a part of reactant. Because the conditions always is introduced at the beginnings of reaction, not in all types of reaction, right? But in some types of reaction, for instance, these types of reactions, which is electrophilic additionality reaction, so not that. So for this reaction, sulfuric acid is going to take part, and then this is sulfate, so we have double bonds with oxygen. Okay, so we have again double bond with oxygen. So we have again what? So how many oxygen does it contain? 4. Okay, so there is your OH here, and then again here we have OH. So we have what? So we have again another bond here, which is OH. So sulfur reacts by using 6 valency electrons, right, to form sulfuric acid. So maybe I think that there it is clear, because how many bonds? 1, 2, 3, 4, 5, 6. So 6 bonds for sulfur. It is element of group 6. So that's why that it reacts. So listen carefully. So let me write it clearly. So what's going to happen is we say that if for electrophilic, we add electrophile first before what? Nucleophile. So when water reacts with lone pair, that's act like what? A nucleophile. We have some one type of nucleophilic or of nucleophile is what? Compounds which contains what? Lone pair, right? Okay, fine. So in this case, here we have CH3, we have CH2, here we have what? Bonds with carbon, then here we have what? We have hydrogen, and then here we have what? We have this one, hydrogens, plus what? Plus water, containing lone pair, and then plus what? Plus sulfur, right? Sulfur, we have what? OH. Or we have, let's say, that this bond, right? And then you can have what? You can have also another bond here of what? Of oxygen, hydrogen. Then here we have that bond with oxygen, we have that bond with oxygen, right? So first of all, we need to have electrophile. In order to have electrophilic addition reaction, we should have electrophile. So what happens, the electronegativity difference between oxygen and hydrogens is greater. So it means the bond will break towards what? This way, right? So oxygen become what? Partially negative, and hydrogens become what? Partially positive, right? Are we together? So then we say that this is what? CH3, CH2, carbon, hydrogen, double bond, carbon, hydrogen 2, and this is nucleophile, plus what? Plus, we can say that we have plus sulfate ion, hydrogen sulfate, but negative ion, plus what? Partially positive. So this is kind of like, let's say, partially negative, right? Are we together? So this bond will break. So the way it will break will be like this way. And then the nucleophile will be added. Right? Are we together? So it will be added. So until it added, these bonds will break. Right? So if it will break, these carbons become the nucleophile and this carbon will become electrophile. So the incoming electrophile will be added to the nucleophilic carbon. Right? So then we have what? We have CH3, we have CH2, we have carbons, we have hydrogen, and then we have a single bond now, we have carbon, so we have added 1 hydrogen. Let's say that this is H2. So this one is what? Partiality, partially positive. Yes, partially positive. Right? And then plus what? So plus water like this, and then plus what? Hydrogen ion. So hydrogen is what? Partially positive. Partially positive. We don't have hydrogens anymore. We have hydrogen sulfate, but partially negative. Huh? Pardon? Okay, so we are still proceeding. So water now will be added onto butane, right? So when it will be added, water will be added by using the lone pair, right? Because it contains two lone pair that I've shown there. So then we have, this is CH3, this is CH2, this is carbon, hydrogen, okay, carbon, hydrogen, and then here we have what? Oxygen, right? We have oxygen, we have hydrogen, we have hydrogen. So it means that there is a bond between what? So this is carbon, this is hydrogen. This is oxygen, this is hydrogen, this is hydrogen. And then there we have what? We have carbon, H, then plus what? Hydrogen, sulfate ion. Right? Okay, but now, if you examine this one, okay, we have added water into butane. But again, there's another challenge. Oxygen cannot form for more than 2 covalent bonds. Oxygen can form only 2 covalent bonds, right? So here, it is how many covalent bonds? 1, 2, 3. 1, 2, 3. So it's saturated, right? So what happens here? We have to break the bond between hydrogens. We cannot break the bond between oxygen and carbon because we formed it. So then the bonds will break. We break in this way, right? So when it breaks in this way, these hydrogens become what? A nucleophile. So CH2, CH now, we have carbon, we have hydrogens, we have OH, then you have what? You have CHE, what? This is CH3, yes, CH3 here, CH3, because we added 1 hydrogen. Hydrogens plus 2 hydrogens become 3 hydrogens. Plus what? Hydrogens as a nucleophile. Plus what? Hydrogen sulfate as what? This are hydrogens as electrophile and hydrogen sulfate as nucleophile. Right? So then this one has to transfer electrons to here. Right? Right? Okay. So then we have what? CH3, CH2, CH, we have hydroxide group here, CH3, plus what? Sulfuric acid. So you see that sulfuric acid, it has participated in the chemical reaction, but when the reaction is complete, we still have sulfuric acid because it was not one of the targeted reactions. It wasn't a targeted reactant. So then, the overall reaction is we have butane, we add so this is hydrolysis of unsaturated hydrocarbons and the presence of what? Of sulfuric acid. So then products will be CH2, CH. This is CH3, but here we have hydroxide. It means this is alcohol now. That is the end product. So you have what? But1. So this we call it but2. If you number 1, 2, 3, 4. but2 all. Right? That's the example of electrophilic addition reaction. So now you can try the homework 07 from manual. Very simple. Let me teach you the second type. The second type of addition reactions, we say it is what? Nucleophilic addition reaction. Nucleophilic addition reaction. Fundamental question for Sir Olenjolain, whenever that he teaches. This is the starting point. What is what? Or define what? What is the meaning of what? What is nucleophilic addition reaction? What is nucleophilic addition reaction? So nucleophilic addition reaction, we say that is the type of addition reaction, in which the nucleophile is added first, in which the nucleophile is added first before addition, okay, then followed first to the organic compound. Organic compound, then followed by addition of the electrophile, followed by the addition of the electrophile to the organic compound. So organic compound. Organic compound. So it's a type of addition reaction. In which the nucleophile is added first to the organic compound, then followed by additions of the electrophile to the organic compound. So you add nucleophile first, then followed by additions of what? Electrophile. So simply, it means that generally, if you have organic compounds, we add what? We add nucleophile first. So this one we add it first. And then we add, followed by what? Electrophile. So we add this one second. Right? So that's the sequence of what? Nucleophilic addition reactions. So we say that these reactions is commonly, we say that it's common for the compounds which contain a pi bond situated between two non-identical atoms. It is common. So what the means of it is common? So when we'll be studying, for example, this nucleophilic addition reaction, right? This electrophilic addition reaction, we are going to study it when we'll be learning about the chemical reactions of unsaturated hydrocarbons. Chemical reactions of alkane, we'll be doing this, and chemical reactions of chemical reactions of alkenes and chemical reactions of alkynes, right? So we are going to do a lot of we'll be finding in different situations the electrophilic addition reaction. So for nucleophilic addition reaction, this is commonly to those compounds which contains the pi bond between non-identical atoms. For example, carbonyl compounds. So when we'll be learning about aldehyde and ketones, we'll be doing a lot of nucleophilic addition reactions. So that's why they say this is a general introduction. So once you know the principles of nucleophilic addition reaction, then learning the chemical reactions of carbonyl compounds is easy for you. right? You see how this is, how building of the foundation is very important. So it is common, it's common reactions to that, common reactions to the organic compounds which contain pi bond between, or pi bond situated between two non-identical atoms. For that to say, for instance, carbonyl compounds. Carbonyl compounds. So carbonyl compounds means ketone and what? Ketone and the aldehyde. Alright? If you have any question, don't hesitate yourself to ask in the comment section. Right? So make sure that you ask. However, that I still have conversation with the owner of this business, that is God, to see even the advanced way of interacting with his students, because something in the comment section there, it's difficult to write a chemical reaction. I don't know if you have noticed about that. Okay, but I've noticed about that one, so I don't know about you. So when you say about carbonyl compounds, it means about 30 aldehyde, and also ketones. And for those who are studying biology, who are doing PCB, who are doing CBG, who are taking what CBN, right? So CBG means chemistry, biology, geography. CBN means chemistry, biology, nutrition. PCB means physics, chemistry, biology. They used to learn these organic compounds in one of the topics that called the biochemistry, right? So they used to learn some structures of ketones and aldehyde, because I told you that the source of organic compounds is animals and plants. So what we are learning in the blackboard is just a part of our bodies and a part of plants. So you're not learning just we are learning hydrocarbons for what? That's the next question. I'm learning hydrocarbons for what? Right? So we are learning what God has created as what we call in science, nature. So we are learning God's creation. So, let me give you an example. This will be example 10. This will be example 10. Example 10. Complete the following reaction with mechanism. The first reaction is this: CH3, and then this will react with a certain reactants. Then I want to do for this CH2, okay, CH3. So these compounds undergo reactions with hydrogen cyanide. So here we have hydrogen cyanide. What will be the product? Here we have also hydrogen cyanide. What will be the product? So this one will be the homework 07, question what? 10, part 1. Right? Okay, so I will do for 1, 2. So solution of 40, example 10, Roman 2. Okay, so stop writing. If you are writing, listen and look on the blackboard. But when you are finishing to copy the question on your exercise book, and you have to make sure that you take it from your exercise book and you keep those information in your mind, in a subconscious mind. Don't leave them in the exercise book because you won't get you won't be using your exercise book to solve a real life problem. So solution of this example, look, we have, this is a ketone, right? Okay, that is ketone. So we say that this is CH3, that bonds with oxygen. So that's why we say that these nucleophilic addition reactions is commonly for the organic compounds which contain pi bond between what? Non-identical atoms. So this is oxygen and carbons, they are not identical atoms, right? So then this one undergo reactions with hydrogen cyanide. Say hydrogen cyanide. Many students, they don't know this compound, unfortunately. For me, I have to do for this Roman 2, okay, excuse me. So this will be CH2. So here we have CH2. Here we have CH3. Okay? So if we carry out that reactions, so what happens there? So you have CH3, this is oxygen, and then you have CH2, or even the bond that I've changed, excuse me. So it is CH3, CH2, we have here, and then CH3. Right? So you want to do the mechanism, how the process will take place. Look carefully. CH2, then you have carbon, then you have that bond with oxygen, and then you have CH3, we have hydrogen cyanide. Okay, so listen carefully. So first of all, this bond is going to break in this direction. Right? Oxygen is more electronegative more than carbon. So the pi bond will break down. So oxygen will withdraw two or pair of 40 bond electrons, and this one becomes partially positive. At the same time, also, cyanide, this is a non-metal. So this is the compound called cyanide, which is a non-metal. This is the hydrogen, right? So it means that cyanide is more electronegative more than hydrogen. So when this one breaks, cyanide becomes the nucleophile and hydrogen becomes electrophile. Right? After pi bond break, oxygen becomes nucleophile, carbon becomes electrophile. Right? So then the next is safe. We have CH3, we have CH2, we have carbon, but this is what? Partially positive. This is oxygen, partially negative. We have CH3, then plus what? We have hydrogen, which is partially positive. We have cyanide, which is partially negative. Right? And then we say that what happens? So what the type of this reaction? Nucleophilic addition reaction. Right? So because nucleophilic addition reaction, how do we define it? We say the type of addition reaction in which we add a nucleophile to the organic compound first, then followed by the additions of electrophile to the organic compound. Right? Okay? So this is the nucleophile. So we add nucleophile first onto our organic compound. Okay? So then we are going to have what? CH3, CH2, we have carbon, but now we have cyanide. Right? And then you have what? Oxygen, which is partially negative. Then you have what? CH3 plus what? Hydrogen, which is partially what? Positive. Right? After adding a nucleophile, the principle tells us we can add now what? The electrophile onto organic compound. So what will be the end product? So CH2, this is this one, and then this is Cn, this is CH3, and this here we have what? Hydrogen. Right? We have oxygen, we have hydroxide group here. Right? So overall reaction is this. But we have CH3, we have CH2, we have double bonds with oxygen, CH3, plus hydrogen what? Cyanide. Okay? So the end product will be what? CH3, CH2, C hydroxide, then this one cyanide, CH3. That's the end product. Right? Everything is clear. In case you have any question, ask it in the comment section. Okay, so that's all about the general introductions of additional reactions as the first type of organic reaction, right? Allow me to take you into the second type of additional reaction, of organic reaction, which is called elimination. Say elimination, so this is 2.2, elimination reaction. Say elimination reaction. Elimination reaction. Have you ever had a reaction that's called elimination? Possibly during when you have been learning about organic chemistry in all of educations, you have learned a little bit about it. Isn't possible? I'm not sure. You know the fundamental question of OLENJOLAI when he's introducing a new concept. So for my students, you can write PO. Okay, today let me change the style. Define elimination. Define elimination reaction. Define elimination reaction. Right? So elimination reactions are organic reactions in which atoms from adjacent carbon atoms are removed without replacement with the formation of multiple bonds. 10. So he said that is the organic reaction, is the type of organic reaction, is the type of organic reaction, is the type of organic reaction, one type of organic reaction, one is the type of organic reaction, in which atoms from adjacent carbons, atoms from adjacent carbons, or from adjacent carbon atoms are removed. Okay, removed. Result replacement. Okay, result replacement. And the results, the formation of 40 of multiple bonds. Result the formation of multiple bonds. So So we say the type of organic reaction in which atoms from adjacent carbon atoms are removed without replacement and result the formation of multiple bond. Let me repeat. The definition of what? Of elimination reaction. Elimination reaction is the one type of organic reaction in which atoms are removed from what? In which atoms are removed from adjacent carbon atoms without replacement and result formations of what? Multiple bonds. What does it mean in general? Listen. Generally, suppose that we have a certain, these are what we call them, so 1 and 2, so this one, for instance, this carbon, these two carbons, we call them adjacent carbon atoms. So for instance, that we have hydrogens, and here we have alkyl hydrocarbons, we have hydrocarbons again, this containing hydrogens, and this containing hydrogens, this containing hydrogen. So this carbon 1 and 2, this we call them sorting adjacent carbon atom. Right? Right? So according to the definition, we say that we remove what? In which atoms from the adjacent carbon. So we remove some atoms. For instance, we remove hydrogen from these carbons, and again remove these hydrogens from another carbon, right? Those are the adjacent to carbons. We remove atoms from adjacent to carbon atoms without replacement. When we remove these hydrogens and these hydrogens, we don't replace them with any other atom, right? But what is going to happen, this also results in formations of 40 multiple bond. For instance, for this case, when we remove this one, so these hydrogens atoms, these are what? Removed without replacement, right? Without replacement. So then, you know what will be the product for that case? We have hydrocarbons, then this is hydrogen, and this is hydrogen, and this is carbon, this is hydrogen, and this is hydrogen, right? This is hydrogens. Here we have what? R. So these two hydrogens have been removed. So when they have been removed, it means that one carbons, for instance, this one become nucleophile and this one become electrophile. So the result formations of 40 pi bond. So then when you have a pi bonds, we don't have these partial negative and partial positive anymore. So this will be the end products according to definition, right? Hopefully, I think you have understood what the general definitions of 40 elimination reaction. Okay, as we said, in case of nucleophilic addition reaction, we say that it's common reaction for carbonyl compounds, which is aldehyde and ketones. And also, when I told you about electrophilic addition reactions, I told that that's the common type of organic types of reactions that we'll find in a saturated hydrocarbons, means alkene and the alkynes, right? For these elimination reactions, it's common. We'll find it means that it's a common reactions in alcohol and the alkyl halides, right? So remember that alcohols is a one of hydrocarbons. Alkyl halides mean that we call it halogens. We call it halogen derivatives of 40 hydrocarbons. So when we learning about alkyl halides, we'll see, or we'll be learning about elimination reaction. And when we'll be learning about alcohols, also we'll learn about 30 elimination reaction. Elimination reaction is commonly, so this is commonly organic reaction. Commonly organic reaction. This is commonly organic reaction. It's commonly organic reaction. It's commonly organic reaction. It's commonly organic reaction of what? Of alcohol So it means that simply say that alcohol, and also what is alkyl halide. Alkyl halides. So remember the functional group for alcohol is hydrocarbons or H. The functional group for alkyl, this is R. Hydrocarbons, R stands for hydrocarbons, H stands for what? Halogen. Okay. So that is about elimination reaction. Then we have, we like to give you an example. For example, that we have dehydrations of alcohol. So dehydrations of alcohol. Dehydrations of alcohol. Very important reaction. Dehydrations of alcohol. Under the concentrated sulfuric acid. This is the one of dehydrations of what? We have certain reactions in preparations of olefins, call it dehydrohalogenations of alkyl halides. For example, dehydrohalogenations of what? Is it dehydrohalogenations of alkyl halides or blood preparation? Not dehydrohalogenation, it is dehydrations of alcohols. So example of this reaction is dehydration of alcohol. So listen, take down this example of elimination reaction. When I will teach you about the preparations of alkenes, right? I will teach you about this reaction. Preparations of alkynes, possibly. You can find also I will teach you about that reaction. When I'll be teaching about the chemical reactions of alcohol. One of the chemical reactions of alcohol is dehydrations of alcohol. Right? So you see that we don't repeat things in organic, but we are insisting in different perspectives so that you can understand. So elimination reaction, I told you that whenever you be learning about alcohol group and alkyl halides, to learn elimination reactions is not an option. Right? Okay. So these reactions will be like this one. So let me put another example. So this is the example 11. Complete. The following chemical reaction with sorting with mechanism. Okay? The first one is this. CH3, CH2, hydroxide, hydrogen. So this is alcohol. So then we want to dehydrate it. Yes, we want to dehydrate it under the presence of concentrated sulfuric acid. But the temperature should range from 160 degree to 180 degree. Right? For you physical students, I taught you yesterday this reaction. But possibly you have forgotten. That's how advanced stuff used to be. Okay? So again, we can take CH3, then CH2, OH. So we pass in chemical sulfuric acid, and the temperature, let's say 170 degrees. So Roman 1 always is homework for students to try. Roman 2, I will do it. So in previous examples, I used to do an example which contained more number of carbons. Today I want you to take that opportunity to do for the organic compounds which have 3 carbons, and I will do for the 2 carbons. The same principle, don't worry about that. Regardless of even you can find maybe ethanol or maybe hexanol, principle is the same. Don't worry, don't panic. Tell it you are my friend. Tell your neighbor, organic chemistry is my friend. Tell your neighbor, advanced chemistry is my friend. Okay? So, solutions for that example 11 and 2. Have ethanol, so listen carefully. Here we have bond between carbon and carbon. We have hydrogen here, we have hydrogen, we have hydrogen. Then here we have hydrogen, we have hydrogen. Then we have hydroxide. So listen, so sulfuric acid for this case is going to be a part of chemical reaction. Right? It's going to be a part of chemical reaction. Or it depends. Let me check if in case of preparations of alkane, dehydrations of alcohol. Because from the general definition of elimination, you say that is a reactions in which that, what? Atoms from adjacent carbons, atoms are removed without replacement. So for these reactions, we are going to remove 2 atoms without what replacement. Look careful. So the first atom, how many covalent bonds do you have? 4. 1, hydrogen, oxygen 1, oxygen, carbon 2, carbon, carbon 3, carbon, hydrogen 4. So where do we experience, where you can find a high electronegativity difference is bond between carbon and oxygen. So this one is going to break. We have partially negative, and this is partially positive. So we have to continue our business. So we have carbon, we have hydrogen, we have hydrogen, we have hydrogen, we have hydrogen here, we have another hydrogen, but here we have partially positive. Then plus what? Plus hydroxide ion. Again, listen. These compounds now, this one, the carbons which have the partially positive, this is what we call inorganic as carbonium ion. If you hear compounds that are called carbonium ion, this one, which have the partially positive. Right? So we have an ion, or it means that organic compounds also it's an ion, which is what cations or an. Don't trust yourself, cation. Okay. So that is the first process. So remember that we say the Adjacency of Alcohols. This is a type of what? Elimination reaction. So because the type of elimination reactions, we are only removing atom from the adjacent carbon, but without replacement. So we have removed the hydroxide in this carbon. So what is the next adjacent atom? This one, right? So what are you going to remove? So here we have electrophilic carbon. So you have to make sure this one is nucleophilic carbons in order to form pi bond. So this bond is going to break. So carbons will become partially negative. Carbons will become partially positive, partially negative, and this one hydrogen is partially positive. Right? So then The next thing, you have hydrogen, carbon, then you have hydrogen, then you have partially negative, then you have bonds with carbon, you have hydrogen, you have partially positive, you have hydrogen here. Plus what? Plus hydrogen. Partially positive, plus hydroxide, partially negative. Then we say that this guy form compounds, and these partially positive carbons and partially negative compounds, they will form pi bond, right? So the end product for this case will be hydrogens, carbon, double bond is carbon, hydrogen, and then you have hydrogen plus what? Plus water, right? So remember that in the presence of 40, still we have our condition, concol, sulfuric acid, temperature 170 degrees centigrade. Similarly, you have concol, sulfuric acid, temperature 170 degrees centigrade. Right? So then we have what? Overall reaction. So overall reaction, we had what? Alcohol, CH3, CH2O, H, and the concol sulfuric acid. And then temperature is 170 degrees centigrade. This one will form what? A sin plus what? Water. Okay, just if so example 12, this is homework, still homework, there are 7. Briefly explain types of 40. Briefly explain types of elimination reaction. Elimination reaction with aid of 40 of chemical reaction. With aid of chemical reaction. Okay? Briefly explain types of elimination reaction with aid of chemical reaction. Then I have a sample. Sample 13. This is the sample of the question. Okay? With examples, define the following. With examples. So this is exam. One of for those days we had a mock exams, we call them ESEP. With examples, define the following. Define the following. Okay, define the following. Number 1, define nucleophilic substitution reaction. I didn't teach you, but I will teach you in the next lecture about nucleophilic substitution reaction. Then define again about electrophilic. I didn't teach you yet. Electrophilic, stay tuned. Electrophilic, make sure that you subscribe. Electrophilic electrophilic, 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 substitution reaction, which I will teach you in the next session. Substitution reaction. Substitution. Electrophilic substitution reaction. Nucleophilic is substitution reaction, and electrophilic is substitution. Substitution. Substitution reaction, and then define electrophilic substitution reaction. Go for Roman 3. Also define free radical substitution reaction. I haven't told you all of this. Free radical substitution reaction. Roman 4, electrophilic addition reaction. Electrophilic addition reaction. Roman 5, elimination reaction. So until this moment, you can only answer two Roman: electrophilic addition reaction and elimination reaction. Roman 1 to 3, you have to make sure that you learn the contents of session 8, where I will teach you about the substitution reactions, because it's a kind of long reaction. Okay? So that's the business that you have to do. So this is the end of session 7. I would like to thank God who have been with me during the preparations, and even at these times, or during at this moment when I've been teaching you. I thank God also who have given you an opportunity to be with me and to learn this material and stuff with me. I'm really praying to God to help you to understand and remember all of this piece of information. In case you have any questions, use the comment sections to ask it, and I'll try my level best to answer your questions, but also you can interact with some other students worldwide. So that is a very important thing that I would like to introduce to you. And I really appreciate your attendance. So I would like to invite you in session 8, when I will be teaching you about substitution reactions as one of organic reactions. Don't miss it. Make sure to subscribe so you get notifications once we upload a new video. And make sure also you go to the descriptions to get more information concerning about this video and these sessions. Share these contents with your colleagues so that your friends, your classmates, some other students around the world, they can have this information, especially in Tanzania. So I would like just to insist you make sure to do the homework and submit your homework in the comment section so that you can see, or I can review what you have got during your practice time. So these contents are for the serious students. Make sure that you are serious so that you can benefit in this program. So may God bless you. I would like to meet you in the next session. So may God bless you and keep you. I'm praying for you. Make sure that you also pray for me so that we may achieve our main objective for this program. See you in the next session.